will be allowed to use not a graphing calculator, but a basic calculator. So the red ones, you can always grab one today too if you just want to practice with it. That's fine. Okay, so there are 6 questions. There's a couple little things like this degree minute second problem that we did very early in the chapter, and then mostly the graphing stuff, and there's a couple of word problems, right triangle word problems. You have to draw the picture and find a missing part of the triangle. All right, so pick a number to start here. We can do one of each. On the test, it'll just be convert one way or the other, not both. 18 we'll do from the top. Okay, and then you want to pick one from the bottom, guys? 24, sure. Okay. All right, so the first one, 45 degrees, 50 minutes, 50 seconds is what we call DMS, degree minute second notation. If you have degree minute second notation, you are turning it into a decimal degree. So to turn it into a decimal, your answer is going to be 45 degrees and something, okay? That's what we have to figure out. That 50 minutes, 50 seconds converts to what fraction of a degree. So really the last 2 pieces are what you're doing your calculations with. If you have 50 minutes, what fraction of a degree is that? Remember, we can think of a degree like an hour in these problems. So if I have 50 minutes, what fraction do I have? 50 60ths. And if I have 50 seconds, what fraction of a degree is that? 3600. And that is what you need to add together and get a decimal and put it in your calculator. So in the red calculators, I would recommend just putting the fractions in parentheses with the division key. It's probably the easiest way to do it. All right, so let's see, 50 over 60 plus 50 over 3600. And then you shouldn't need to round these. They're going to be rational because we're adding fractions together to get them. So I just usually put a bar over whatever repeats if something does repeat.
What did you say was the easiest way to like deal with the kind?
So how I would type it in is like this: 50 and then the division key 60 plus, and then the same thing for the other one. Just parentheses with the division key for any fraction. Okay. All right, so that's the answer for that one. The one at the bottom, if you are converting the other direction. So I have 110.433 degrees. We want to convert this into degrees, minutes, seconds. So that's what our answer is going to look like. The degree part should not change, 110 degrees. And again, just the decimal is going to convert into minutes and seconds. Right now, the decimal that we have, 0.433, is a degree. It's like an hour, okay? And I want to first convert to the next unit, minutes. So if you had hours and you wanted to convert to minutes, what would you do? If I said 2 hours, how many minutes is that? What would you do? That's what we're doing. Multiply by 60. 0.433 times 60 gives me 25.98. The number in front of the decimal, 25, is your minutes. And then we still have part of a minute, 0.98. So we're going to convert that now to the next unit. That's what's left over. So if I have minutes and I want to convert to seconds, what do I have to multiply by? 60 again. So 0.98 times 60 gives me 58.8. This final number, if it's still a decimal, you're going to round to the nearest second. So I'm going to say 59 seconds. Okay. Any questions on that one? All right, next. Okay, number 8 is going to be a word problem. And there's 2 word problems. In one word problem on the test tomorrow, you're going to have to solve for a side length of a right triangle. In the other one, you're going to have to solve for an angle in a right triangle. When in doubt, they are both right triangles. That's the picture you should draw. And you are using SOHCAHTOA for both of them. So this is really just stuff from, again, the beginning of the chapter. All right, go ahead and pick a problem. Oh, I don't know. 65. Okay. All right. Find the height of a pine tree that casts a 93-foot shadow on the ground if the angle of elevation of the sun is 24 degrees, 35 minutes. Okay, here's my pine tree. That's a pretty good pine tree. Okay, here's its shadow on the ground, and that's my 90-degree angle. Anything, remember, sticking out of the ground, that's your 90-degree angle. Okay, it said angle of elevation. So we talked about two different angles that could possibly happen in our right triangles. Angle of elevation is if you're on the ground looking up. Angle of depression is if you're at the top looking down. And the angles are always formed between the line of sight, which is the hypotenuse, and a horizontal. Okay, so if I was at the top of the tree, the angle of depression would be between that dashed line and my hypotenuse. Angle of elevation is if I'm at the bottom looking up. So this is our theta that we're given. And in this case, it is 24 degrees, 35 minutes. Like that. Okay. All right, what else do I know? Find the height of the tree. That's my x. And the shadow on the ground is 93 feet long. Okay, so here we are obviously solving for a side length. So then we look at our angle in our triangle and we decide how are the sides that we know or are solving for related to that angle. So are they opposite, adjacent, hypotenuse? What do we have? I have x is opposite and 93 is adjacent. So if you have opposite and adjacent, which trig function is that? Tangent. Okay, so tangent of my angle, 24 degrees, 35 minutes, is x over 93. Opposite over adjacent. How do I solve for x? Times 93. So 93 tangent 24 degrees 35 minutes equals x. Okay. In your calculator, you can turn 35 minutes into a fraction if you want to. So here's how I would type this in. First of all, double check in the calculator that it is in degree mode for this problem. And actually for the other one also you want to be in degree mode. So it should say on the red calculators DEG. And we can check that tomorrow when you guys get them just to make sure at the beginning of the period. Everybody in degree mode? Okay, so let's pretend you had a red calculator. Here's how I would type this in. I would type in 93 tangent, and then in my parentheses, 24 plus, now remember 35 minutes is 35/60th. So that's what I'm typing in, and I'm just going to put another parentheses there, 35 over 60, and then end both parentheses. Does that make sense? Okay, so you don't even need to mess with like decimals or reducing fractions or anything. Just type it in as exactly what it means. Okay, and then if you're in degree mode, you should get, let's see, I'm not in degree mode, so that's not the right answer. Hold on. 42.5 degrees. Okay, and so to the nearest degree, I would say, if it asked that, 43 degrees. No, 40, it's not degrees. What is it? I'm thinking of the wrong thing. It's height in feet. There we go, that's better. So to the nearest foot, it'd be 43 feet. Okay. Any questions on that problem?
You said there's like two types of problems.
Yep, and we'll do another one.
Okay.
It's later on. I think it's like number 11 or 12. Yep,
So is it only asking for like one thing, or is it?
It's going to ask you to find one thing and one thing only. Yep. Other questions? Okay. All right. Next, number 9 is going to be one of the graphing problems that you guys have seen that you did in your packets and what you did on your quiz, which that quiz and packets, you guys have those back. So those would be great little resources to kind of look at and study with. It's going to be, make sure you know your key points, name all the properties, plot the points. That's going to be the setup. Number 9 will either be a sine or a cosine function. So you need to make sure you know the key points for sine and cosine. Remember, they're all the same radians. Okay, make a mental note. Okay, we need to know those for tomorrow. They're all the radians around our unit circle, all of our quadrant angles, and then either the sine or the cosine that goes with them. Okay, so let's pick one. What do we like? 45. Okay. Well, let's pick one with like a fate. You want to add a number to the end of that? Let's pick one that's got all the things in it. 51 or 52. Yeah, let's do one of those. Just make sure we cover all our bases. Which one? 52? Okay. All right. Okay, and I'll write it a little bigger for you. So we've got y equals -1/2 cosine 2x minus pi over 2 minus 3. Is this equation in the form I want it to be in? Yes, okay. They factored nicely that 2 out for me. If it wasn't factored out, I'd want to make sure I do that first. Okay, then the next thing I would recommend doing is naming, like we practiced, scale changes and translations. So scale changes were the reciprocal of b times x and a times y. What is the reciprocal of b in this problem? 1/2 x, and then a times y, which is, that's not my a, -1/2 is my a times y. Okay, translations were x minus c, y plus d. So my x will look like what? Yep. Opposite sign from what we see in the parentheses there. And then my y, -3. Okay, so now I'm going to set up my key points. I'm not going to have the parentheses set up on the test for you guys. Mrs. Talarchuk teaches her students a little differently. They don't use the parentheses, so we didn't put them on there, but you'll have space to put them on there. Okay, key points. Whether it's sine or cosine, it starts with 0, pi over 2, pi, 3 pi over 2, and 2 pi. It's just every pi over 2 radians, every 90 degrees around my unit circle. Then you look at what the function is. This is a cosine function. So then I want to think about, okay, what are the cosines on my unit circle of all of those values? What's the cosine of 0? 1. Pi over 2, pi, 3 pi over 2, and 2 pi, 1. Okay. Then we perform scale changes, then we perform translations, and we already wrote the rule. We just have to do the math. Okay. And the more of this you show, the more partial credit I can give you just in case something goes wrong. All right, so I need to take each of my x's and multiply by 1/2. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. Take each of my y's and multiply by -1/2. So -1/2, 0, +1/2, 0, -1/2. Okay, then I need to take each of my x's and I need to add pi over 2. Remember, you might need to get common denominators, do a little work in the margins or on your unit circle. You'll get that back tomorrow. Okay, so 0 plus pi over 2 gives me pi over 2. Pi over 4 plus pi over 2 gives me 3 pi over 4. Pi over 2 plus pi over 2 is pi. 3 pi over 4 plus pi over 2, 5 pi over 4. And pi plus pi over 2, 3 pi over 2. All my y's, I need to subtract 3. Decimals are fine. -3.5 is going to be my first one. So subtract 3. Hi, this is Nicole. Hey. Okay. Okay. Sure, yes. Okay, bye. Okay, 0 minus 3, -3, 1/2 minus 3, -2.5, -3, and -3.5. Okay, and then if you don't like how the axes are numbered, you can always change that if you feel like something would fit better. I think this one's okay. Pi over 2, I'm at -3.5. Remember, you should see a wave shape. All your points should be about the same distance apart if you're doing it right. 3/4, I'm at -3. Pi, I'm at -2.5. 5/4, I'm back at -3. 3 pi over 2. I'm back at negative 3.5. So there's my one period of this cosine function, and then we want to make sure we don't go above or below those boundaries we've created already, so just make sure you turn it around when you draw your arrows. Sorry. Okay, thank you. All right, so now let's just name all those properties that we've practiced. Let's start with period. Remember how to find period of sine and cosine. You can use 2 pi over b, or you can just figure out how far apart the points are that you plotted. Here b is 2, so if I do 2 pi over 2, I just get pi. Amplitude, what's that going to be? A half. It's just the absolute value of a. Phase shift, opposite of c. Positive, pi over 2, yep. Okay, domain. Correct. Negative c, opposite of c. So it's whatever you see in that first part of the translation rule, positive pi over 2. Range. Yep, and make sure we use brackets on those. And then the last thing is the sinusoidal axis. It's y equals whatever your d value is at the end of your equation, or the middle of your curve, if you want to look at it there. Make sure you put y equals in front of it because it's that horizontal line that cuts our graph in half. Yes?
So going back to the translation.
Uh-huh.
This is y plus d's for the, that's good for me, so she is.
Mm-hmm.
So why do we do y minus?
So because d is negative 3. So we're doing plus negative 3, which is minus. So does that make sense? So you just got to remember for the translations, the first part of it is always the opposite sign from what you see in the equation. The second part of it is the same sign you see in the back of the equation. You only change the one in the middle.
This one, pseudo axis, is that d minus, wait,
It's y equals whatever your d value is. And here it was negative 3 at the end. Yep.
Is there another way to find the sinusoidal axis?
I mean, you could look at the graph and see that y equals negative 3 is the horizontal line going through the middle of it. Yep. Other questions? Okay. All right, that's the first half. So we're on to our next word problem now. This one, it's a little different than the test. I'm not going to give you a picture on the test, but there also won't be 2 triangles. There will only be 1 triangle where you have to label, kind of like the last one. So this is, I don't know. These are the only ones that were in your book, so that's why they're on here. But either way, you're going to draw a right triangle, you're going to label, and you're going to solve for an angle inside the triangle, which is what we're doing in this problem. Okay, so pick a number, 87, 88, or 89. 89. Okay, I'll draw this a little bigger for you. So we've got 2 kind of mini triangles happening here. Here we go. There's a couple right angles. So this is 440. This is 880, 110. And we are solving for theta, which is the angle that spans both of those triangles. Okay, so like I said, there'll only be 1 triangle when you do it tomorrow. So what we're going to do is practice kind of 2 mini examples within this. So these are not obviously the same triangle. They're not congruent triangles. So I have 2 different angles I need to solve for. I need to solve for angle x on the left, and I need to solve for angle y on the right, and then I need to add those together ultimately to get theta. Okay, so let's talk about x, that triangle on the left. How are 440 and 110 related to it? It's going to be a tangent. Tangent of x equals opposite 440 over adjacent 110. And then y is going to be tangent again. But it's going to be 880 over 110. Again, in your calculator, you want to be in degree mode because we want a degree answer here. And it's the same as the graphing calculator. You just hit second, tangent, because we're going to use an inverse tangent when we're solving for the angle. Inverse tangent, inverse tangent, inverse tangent, inverse tangent. And it's going to cancel out the tangent, and then what you have on the right side is what you're typing in. So if I do in degree mode, the inverse tangent 440 over 110, I get 75.96 degrees. So I'm just going to round to the nearest degree and say 76 degrees. If I do the inverse tangent of 880 over 110, I get 82.87, so about 83 degrees. And then add those together to get theta. So theta, 76 plus 83, grand total of 159 degrees would be the answer.
So on the real test, it's only gonna be like.
It's going to be one right triangle, but I'm going to tell you, like, you know, this side is this, and this, you're going to have to label it kind of like the other one we did already. You'll just have two sides and not know the angle, versus in the last example we did, you had an angle and a side and had to solve for a side.
And wait, why did you do inverse?
Because that is what I need to do to get that x alone in this case. So the only way to cancel out a tangent or a cosine or a sine, whatever function you're using, is to use its inverse function.
Oh.
We didn't have to do that in the last word problem because, where did it go? There we go. I wasn't solving for what was next to the tangent. I was solving for what's on the other side. Okay, but if you're solving for an angle, you're going to have to get rid of the trig function, so you're going to have to use an inverse to do that.
Okay, so I'm using the inverse, gets rid of the x.
It gets rid of the trig function. And that's what I need to do in this equation. I need to get rid of the trig function because I'm solving for x.
Oh, okay.
Okay? Now in the other one, I knew what was next to the trig function, so I didn't have to get rid of it. I had to get rid of something over here, so that was different. Okay. Uh-huh.
So on the test, it will just be like portion X.
Yes.
Okay.
But you're going to have to draw the triangle.
Yeah, yeah.
Yes. Mm-hmm. Okay. Other questions? All right. Okay, two more. You need to know for tomorrow, these were in section 5.1, this was a while ago, your two formulas for arc length and area of a sector. And remember, for both of these, theta is a radian. So this will be on the test like a part A, part B problem. I'm going to give you some information about a circle, and you're going to have to find the arc length for whatever is being asked and the area of a sector for whatever is being asked. So we can do, I don't know, we can pick one of these and just solve for both things if you want to. That's fine. So pick a number. 68, sure. Okay. So in 68, I have a radius of 6 meters. And I have a theta of pi over 6 radians. Remember, if it was not a radian, you would have to convert it first. If it's a degree and you want to convert to a radian, like let's pretend it was 25 degrees, I would have to multiply by pi over 180 to convert it into a radian. And as far as it goes, like on the test, if I had to plug that into a equation, I would not even try to round it because it's going to be a decimal and you're going to be off if you try to round it. I would just leave it as that, 25 pi over 180. Can that reduce? Yes, but it's not my final answer anyway, so I'm not even going to play with it. Okay, you can type exactly that in for the theta then, if you need to. Yeah.
You always have to convert that to radian.
It has to be a radian for this version of the formula. There are other versions of the formula that account for a degree, but our book doesn't use those, so you just have to remember it's got to be a radian before I plug anything in. Okay. All right, so arc length is just r theta. So 6 times pi over 6. That I can do in my head. That's pi. We don't leave answers in terms of pi because arc length is a length. So we're going to say about 3.14 meters would be my answer there. Area of a sector is 1/2 times r, which is 6, squared, times theta, which is pi over 6. And if I were you, I would just type that in one line exactly as you see it in your calculator, because the decimal is what we're going to ultimately want anyway. So 0.5 times 6 squared times pi divided by 6 gives me approximately 9.42. And remember, this is an area of like a pie piece if you were to draw it. So in this case, it would be meters squared. I am giving you a point for labeling. Okay, so like this problem, I want to see a label. The word problems, I want to see a label. Feet, meters, inches, whatever it is. Okay, label, 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 whatever it represents. All right. Yes.
How do you plug in your calculator? Is there a pi?
There is a pi on there.
Oh, you can use what 3.42.
You could use that too, but I'm trying to remember where the pi button is on there.
Is it just a button? I think it's just a button.
Oh, yeah, right here. Oh,
There it is.
sorry.
Even easier than the graphing calculator on that one, yeah. Okay. Any questions on that?
Is it show up like that or is it?
It will be in words, but it won't be a word problem. It'll say the radius of the circle is this, and the central angle is this. Find the arc length and the area of a sector.
And it's just always.
Well, it was meters here because my radius was meters, but it could be, you know, feet or inches or yeah, whatever. Yeah, just whatever's your unit for the problem is. Special.
So what is 60?
What is what?
What is 60?
6 is, yeah, that's r. It's our radius. So if I were to draw this, okay, so my radius is 6 meters, and my central angle, theta, is pi over 6, so about 30 degrees. I mean, that's not like super drawn to scale. But what you're finding here is two things. So you're finding this distance is s, between that initial and terminal side of that angle where it intersects the circle. And then the area of this little piece is A, the area of the sector. That's what we're solving for.
So pretty much we just did like S, like this would be part A, so like part A would be like S finding S.
Yep.
What's the difference between like 65 through 68 and 73? They have A equals.
It only asks for one or the other, but
Oh, right.
if we had picked one of those, I would have made you solve for both anyway. You're going to have to solve for both. In all of them, you're given the same two pieces of information. You're given R and you're given theta. Yeah. Okay. All right, we just got one more problem. And it's the last graphing problem. It will, on the test, either be tangent or cotangent. So you do not have to worry about graphing secant and cosecant. But again, you need to know the key points for tangent and cotangent, or be able to like imagine what that one period of the graph looks like to be able to get the key points. Pick a number. 27, sure. Okay. Y equals tangent, and there's no number in front there. You can put a 1 there if you want. 2 x plus pi over 2. Okay, and they are again already factored the 2 out for us. If they didn't factor the 2 out, you'd want to make sure you do that first. Scale change and translation rules are the same as before. Okay, so scale changes are reciprocal of b times x and a times y. Reciprocal of b is 1/2 x. A times y is just 1y, or you can just say y. So the y's aren't going to change there. Translations, x minus c, x minus pi over 2. And then if you look at all of these, usually these functions did not have a shift up or down. So we're just going to say y plus 0 or y. You don't have to worry about that happening. All right, so key points. Let's see if I can move my graph over a little bit. Where's my... oh well, I'll just move it down. How about that? Okay, key points. Tangent and cotangent are different. If it is tangent, you're going to start at negative pi over 2 and end at positive pi over 2. I would say that's probably like the minimum that you want to remember. It's quadrant 4 to quadrant 1 is where that's happening on our circle. And then you just find out what's in the middle of those. What's in the middle of negative pi over 2 and pi over 2? 0. And what's between 0 and pi over 2? Pi over 4. And what's between 0 and negative pi over 2? Negative pi over 4. Okay, as soon as you have the radians, Again, the y's are just the tangent at that number on your unit circle. So like tangent of pi over 4 is usually pretty an easy one. What's the tangent of pi over 4? 1. And what's the tangent of negative pi over 4? -1. And then remember, we set these up in such a way that they start and end at an asymptote, and right in the middle is a 0. Those are the other tangent values. Okay. Then we do scale changes, and we do translations. 1/2 times my x's, negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. The y's are getting multiplied by 1, so they're not changing. Undefined, -1, 0, 1, and undefined. My translations. Take each of my x's and subtract pi over 2. The y's, again, are not going to change. So I'm just going to put those in there. What is negative pi over 4 minus pi over 2? Minus 3 pi over 4. Negative pi over 8 minus pi over 2. (5/8). 0 minus pi over 2, negative pi over 2. Pi over 8 minus pi over 2. Close. -3 pi over 8, that's it. And then the last one, positive pi over 4 minus pi over 2. Negative pi over 4. That's right. Got it. Okay. Now we graph them. 2 of them, and again, you can renumber the axes if you don't like how it's numbered, are at -3/4 and -1/4 pi. So they're in there on my axes. In the middle of those should be a 0, negative pi over 2. And then on one side it should be above the axis, and on the other side it should be below. At -5/8 it's below, at -1, at -3/8 it's above, at +1. And remember, when you connect these, it should look like a cubic sort of shape that's happening there. All right. Properties. What is the period of tangent or cotangent? Do you remember how to find it? This time pi over b instead of 2 pi over b. B here is 2, so if I do pi over 2, I get pi over 2. Domain of these guys. Okay, so all reals, negative infinity, except the asymptotes. Yep. Okay, range. All reals, up and down forever. Okay, phase shift. Same rule as before, opposite of C, negative pi over 2. Okay, then for these, is there an amplitude of these? There is not. Amplitude is just something we talk about with a wave shape. All we have for these are asymptotes and zeros are the two things that you could be asked. Okay. Asymptotes. Can you give me one place where we have an asymptote on this graph? Sure. Negative pi over 4. You could also say -3 pi over 4 there. Would be fine. Plus, what do I always add on with these? The period times k. The period is pi over 2, k, and then what do you want to say about k? K is an integer. You need to say that on the test. Yep, my computer's being a little jumpy here, but because it's saying we're done. I've been talking too long. I feel like it gives me a notice at some point. Okay, and then zeros. Where do we have a 0 on this graph at? Negative pi over 2, and then again plus the period times k. So actually this one you could just say like 0 plus pi over 2k or just pi over 2k. And again, it's not letting me write there. Do you guys want to put on your paper the key points for cotangent? Because they're just slightly different. Okay, my computer's not writing very well, so I'm just gonna put them on the board here. Okay, so if it's cotangents, 1, 2, 3, 4, 5. You start at 0 and end at pi. Okay. By the way, these are the same two quadrants that the inverse functions are defined in. Inverse tangents in 1 and 4, and that's what we use, 1 and 4 for their key points. Inverse cotangents in 1 and 2, and that's what we use for those key points. That's why we use them, because they're the period of the graph. Okay, so cotangent starts at 0, ends at pi, in the middle is pi over 2, and in the middle of those, I get pi over 4 and 3 pi over 4. Again, it starts and ends at an asymptote, just like tangent. It's got 0 in the middle, just like tangent, and then you just have to remember what's the cotangent of pi over 4. 1, 3 pi over 4 is going to be the negative, so the difference, if you look at the basic graph, tangent's going to go up from left to right, cotangent's going to go down from left to right. All right, so again, could be either of those for the graph, could be sine or cosine. Same radians for both of those, though. All right, so you have no homework other than just study. You've got extra Polaris problems. I'll be here in the morning if you need me. Other than that, we'll do tests tomorrow, and then you guys have a weekend with nothing to work on. Unless you're really bored and you want to look ahead. You're like, I don't think I'm going to do that board. Sure, yeah. All right, let me do self